In this final video of my series on panel data regression, I show how the Hausman test is used to determine whether fixed effects model or random effects model should be selected. By this process, we're trying to determine which model results are more reliable, in the sense that we have parameter estimates that are not only unbiased but also and in particular efficient and consistent. The null hypothesis underlying the Hausman test is that the random effects model is the appropriate estimator. A rejection of that means that the random effects are probably correlated with one or more of the regressors, in which case fixed effects model is the right way to go. And so in a nutshell, the null hypothesis says go with random effects. And if we reject that, then we're going to go with the alternative, which says go with fixed effects. So let's show it up on eViews real quickly. So here's what I got here. My dependent variable is market capitalization, and my explanatory variables are capital expenditure and book value of equity. I'm going to right click on any of these and open as equation. And when I do so, I go to panel options, and for cross section I go to fixed. I click on fixed. Now I'm going to have to run fixed effects model first, and then afterward I run random effects. You got to do that in those two stages to be able to perform Hausman tests. So click OK. Alright, so here's my fixed effects model results. Alright, and then I'm going to go to estimate and then go back to panel options, and for cross section change it to random and click OK. And here's what I got here for random effects results. And then to perform Hausman test, go to view and scroll down here to fixed random effects testing and hover across to correlated random effects Hausman test. Click on it, and here we go. There are three parts to this. The first and most important is Hausman test results, which you can see already that we're going to have to reject the null hypothesis because p-value is less than 1%. The second part is a test of significance on the differences in the model coefficients between fixed and random. And the bottom third is a repeat of fixed effects model results, which is the preferred model. So I've kind of cleaned this up a little bit and placed it right here on my PowerPoint for better clarity. Alright, so this is the top portion which shows output for Hausman tests. The test statistic that you see here is chi-square distributed with k-1 degrees of freedom, where k is the number of parameters including the intercept. So that's beta sub 0, beta sub 1, and beta sub 2. 3 of the minus 1 is 2. That's what you see right here. This is the p-value, which at any conventional level of significance you'd have to reject the null hypothesis in favor of the alternative, which says go with fixed effects. The middle portion shows a comparison of fixed effects and random effects coefficients of each of the regressors. And you can see here that although the coefficient signs are identical, the values of the coefficients are a bit different. And this is a confirmation, this test, that the differences are statistically significant. At the 1% level, we reject the null hypothesis that the coefficients for capital expenditure are the same across the two models. And at the 5% level of significance, we reject the null hypothesis that the book value of equity coefficients are the same for the two models. And finally, the bottom portion shows results of fixed effects model, which Hausman test identifies as the correct model, which we've seen before. In conclusion, if the coefficient between the cross-section random error term omega and one or more of the regressors is 0, and given that there is no zero correlation, pooled OLS should be quite okay. However, if there's evidence of zero correlation, and given that this covariance is 0, then random effects model is the way to go. Now then, if the covariance between the cross-section random error term, the heterogeneity term, and the regressors is non-zero, then we're going to have to estimate the panel model using fixed effects model, because we can be sure that it'll give us unbiased and, more importantly, consistent parameter estimates. Now we want to note though that both fixed effects model and random effects model account for firm heterogeneity. In fixed effects model, the heterogeneity is assumed fixed within each firm, as we learned. In random effects model though, the cross-section random error term omega is reflected in the random variation between the common intercept shared by all firms in the same business environment and the intercept value of each of the firms. Now, importantly, unlike fixed effects model, which ignores time constant variables, random effects model allows us to estimate their effects, as we have learned. Now, a mixed effects model not discussed in the series includes both fixed and random effects. That's all, folks. Thanks for hanging out with me, and let's keep learning.